Hi y'all, so it's Sunday afternoon and I'm getting ready for the new week, and I hope that you had a good weekend and are ready for another round of calculus. So we are continuing our study of integration today. So I have showed you the basic rules so far, but there are some integrals that you will have to find where you can't directly apply one of the rules. So the method that we're going to begin talking about is called integration by substitution. And it's also called U substitution because what you basically do is you change the variable to a U and you substitute back into the original function. So doing that will be called integration by substitution. Now there are easy ones and there are more difficult ones, so we're going to do this in parts. It won't be all today. I'm going to do some easier ones today just so you have an idea of what the process is, and then I'll do a couple more videos after this that will do some harder ones. So today will be fairly easy, but I want you to at least get the process down today. So I want you to remember that integration and differentiation are related to each other. So finding derivatives and finding integrals are inverses of each other, means that one of them undoes the other one. So an integral undoes a derivative, and a derivative undoes an integral. Okay, so that will come into play in the lesson as well. So back in January, when we were finishing up our derivatives, we were learning the chain rule, and that was something that was kind of more complicated for some of you, and this is kind of like the reverse of the chain rule. So we're going to do some easy ones today, like I said, and then some harder ones later. Okay, so let's get to it so you can see what I'm actually talking about. Okay, so these 5 that we're doing today will be not so bad, and then later we'll do some harder ones. Okay, so for number 1, we have an indefinite interval. And remember, it's called that because there are no numbers here and here to say that we're only going from a certain interval. So this is indefinite. And then we have x plus 1 cubed, and then dx. That's a 3. I should make that better. Okay, so if you look at all of your integral rules that I gave you in a previous lesson, you will see that there's nothing that allows you to directly apply one of those rules here. And it's because we have something inside of the parentheses raised to a power. So this is not a typical polynomial. So we're going to do what is called U substitution, and we're going to introduce a variable U. So over to the side, put U equals, and what you will do is take the part that's inside of the parentheses and use that as U. So it's going to be U equals x plus 1. Okay, then you're going to take the derivative of U, and we're going to use the notation du and dx, and we did that earlier in the year, but it's been a while ago, so it's going to be important to be able to evaluate this integral. So please, do what I show you, and it will make the process much easier. Okay, so to do the derivative of u, you would just say it's du. And on the other side, this is just a typical polynomial. So remember, think of that as x to the first power. So the rule for derivatives was to take the power and multiply it to the front of the x, so that would be 1. And then you would have x to the, and then you would subtract 1 from 1, so that would be 0. And then the derivative of a constant 1 is just 0. So those are rules that we studied earlier in the year. And you want to include dx with that, like derivative of u, derivative of x. Okay, so now we're going to clean this up a little bit. Du will equal. Now in algebra, you learned that any number raised to the 0 power is 1. So this is really just 1 times 1, which is 1. And then of course that's 0. I'm not going to put plus 0, and then I still have the dx. Well, we know that multiplying 1 by something makes it the same thing, so in this case, du will equal dx. Okay, so what I'm going to do is I'm going to substitute these u's back into the integral that we're trying to solve. So we're still going to have the integral symbol, but in place of x plus 1, I'm going to use u. and it will still be to the third power. And then instead of dx, I know that du is the same thing, so it will look like that. We're doing the integral of u cubed du. Okay, so now we would be able to follow the integral rules that we've studied recently. So consider the u to be a polynomial cubed. So we've done this just not that long ago. So remember, what you do is you think the exponent, add 1 to it, so that would be 4, and you would write a fraction, 1 over 4, keep the u the same, and then the exponent would also be 4. So remember, the denominator and the exponent should be the same thing. And then remember, in each case you put plus c for any constant. Okay, at the very end, what you will do is go back to whatever you set u equal to up here. You don't need the 1, and that would be x plus 1, and you would plug that back in for u. So it would be 1/4 times x plus 1 to the 4th plus c. And this would be your answer for number 1. Now, in the directions it says to check your answer. So this is something that I want you to do because these are not that bad. So checking your answer means if you took the derivative of your answer, it should be what you started with back here. Because remember, derivatives and integrals are inverses of each other. So let's try to take the derivative of this one. So we did this back in, I think, about January. It's called the chain rule that we would use, and I know that's been a while back and you may have forgotten. So here's the rule. What you do is you take the exponent and multiply it by the number in front. So that would be 4 times 1/4. Then you keep the inside the same. You subtract 1 from the exponent, so that would be 3. And then the last part of the chain rule that you can't forget is to do the derivative of the inside. Well, we went over this a little bit ago. The derivative of x would be 1, and the derivative of 1 would be 0. So I'm not going to write times plus 0. Okay, so if we clean this up a little bit, 1/4 and 4 become 1. So I wouldn't need to write a 1 in front of the parentheses. It would just be x plus 1 cubed, and then also times 1 again. So I'm not going to write that. So compare what we got here to what we got here. Like, see how the original function was x plus 1 cubed, and after we took the derivative of this, we got x plus 1 cubed. So that means that this work is correct. Okay, so I know that was a lot of work to get one simple answer, but the process that we just followed is important because when we do some more difficult ones, not in this video, but in other videos, that process will be the same. So it's going to be important that you follow exactly what I just did. Okay, so let's try another one. So for number 2, we've got an integral, indefinite integral, and this time it's 5x plus 2 raised to the 7th power, dx. Okay, we're going to do what is called u substitution again. So I'm going to take whatever's in the parentheses here and call that u. So u will be 5x plus 2. Now I'm going to take the derivative of that. So the derivative of u, you'll put du. The derivative of 5x, keep in mind that the x is really to the first power. So you would multiply that by 5, that would be 5. And the x would be x to the 0 power because you would subtract 1. So there would be no x, so it's just 5. And then the 2 is a constant, so the derivative of a constant is 0. So I'm not going to put 5 plus 0, it'll just be 5. But remember, we're going to include dx, derivative of x. Okay, so I want to substitute back into the original problem. So I want to have a value for dx that I can put here in terms of u. So what you want to do over here is to eliminate the 5. So I'm going to divide both sides by 5. That will cancel out the 5s, so then I'll have du divided by 5 equals dx. Okay, so now I'm going to go back and substitute in u to this problem. So I'm still going to have the integral symbol, but in place of the 5x plus 2, I'm going to use u, raise it to the 7th, and instead of dx, I'm going to put in du over 5. Okay, so one thing to note is the dividing by 5 really is the same thing as 1/5, because think of this as 1 du divided by 5, so it's the constant number 1/5. So what I'm going to do is factor out the 1/5 by putting it over here before the integral sign. That way I won't have to deal with the 1/5 now. That will come a little later. Okay. So then I'm going to take the integral of u to the 7th power. So let's think about that. We just have recently done those rules. So keep the 1/5 over here on the outside, and then you may want to use parentheses. So think, what are we going to do with u to the 7th power? Okay, so you look at this exponent and think, add 1 to that, so that would be 7 plus 1, 8. So we would have 1/8 u raised to the 8th power, and then plus c. So 1/5 times 1/8 u to the 8th plus c. Remember, c is just any constant. Okay, so to simplify this a bit, I'm going to multiply 1/5 by 1/8. So just going straight across, that would be 1 over 40 u to the 8th plus c. And at your final step, all you want to do is go back and see what u is and plug that in. So in that case, remember u was 5x plus 2. So it would be 1 over 40. U is the 5x plus 2 raised to the 8th plus c. Okay, so that would be your answer for number 2. Now the directions say to check your answer. So that means we are going to need to take the derivative of our answer and see if it equals the original problem. So let's try that. All right, so what we would do is first multiply the 8 exponent by the 1 over 40. So think of 8 over 40. 8 over 40 is the same thing as 1/5. Then we would keep the inside the same, so that would be 5x plus 2 to the, now after you take the derivative, remember it's the 7th power, it's 1 less. And then also you have to multiply that by the derivative of the inside. So the derivative of 5x would be 5, and the derivative of 2 would be 0. So it's just 5. Okay, so now look at the fact that you have a 1/5 at the beginning and a 5 at the end. So you would multiply those. So 1/5 times 5 would be 1. So you would end up getting just 5x plus 2 raised to the 7th power. And notice that that matches what the original problem was. So if you do the derivative, that's what you want to happen. You want the answer to be what you started with, because derivatives and integrals undo each other. All right, so I know that's a lot there. So this is the final answer for number 2. This was just checking our work. Okay, so for number 3, we've got an integral, indefinite integral, 5x to the 5th power dx. Okay, so first of all, we're going to use a u, and u will be what's ever in the parentheses, so that will be 5 minus x. You're going to take the derivative of that, so the derivative of u would be du. The derivative of 5, that's a constant, so that would be 0. And the derivative of negative x would be -1. And then put dx. Now I'm trying to substitute something back in over here for dx in the next step. So I'm going to divide both sides by -1. so that those ones will cancel out and you'll have dx equals something. So in this case, if you have du divided by -1, that would be negative du. So now we're going to go back over here and fill in the u's. So we'll still have the integral sign. And right here, I'm going to use u to the 5th. And it's negative du times negative du. Okay, when I take the derivative, I don't want to deal, or not derivative, integral. When I take the integral, I don't want to deal with this negative sign. So like in the last problem, I'm going to take that negative and just put it over here in front of the integral. It's okay to do that. And then I won't have to worry about that negative sign. So now I'm going to take the integral of u to the 5th power. So remember, you look at the exponent being 5, you add 1 to that, that would be 6. So you would have 1/6 u to the 6th power, because remember those two things should match, and then plus, oops. When I do the integral, I don't want the integral symbol there anymore, so I'm going to put the negative outside of parentheses. So it's like that. Negative, and then 1/6 u to the 6 plus c. Okay, so in your last step, you will go and plug in what you originally had for u. So remember, u was actually 5 minus x. So now the negative sign, you can put it with the 1/6. So you can say it's negative 1/6. In place of u, put in 5 minus x, raised to the 6th power, and then plus c. So that should be your answer for number 3. Now to check it, remember you take the derivative of what your answer, and it should match what it originally was. So let's try that. Okay, so the rule would be to multiply 6 by the fraction in the front. So that'd be 6 times negative 1/6. You would keep the inside part the same. The power would be 1 less, so that would be 5. And then you have to take the derivative of the inside. So the derivative of 5 would be 0, and the derivative of x, negative x, would be -1. So you would be multiplying by -1. Okay, so now we have to check and see if that's really the same thing as the original. Well, over here, 6 times negative 1/6, that would be -1. So all of this is -1. But then over here, I've got another -1. So think of it as -1 times -1, which is just 1. So I'm not going to write a 1. All of that would just cancel out. And you would have 5 minus x to the 5th. And notice that that was the original problem. So that means our answer is good. This is the integral that we needed back here. And remember, you can stop and pause the video and come back if you need to, rewind it, whatever works for you. Okay, so the 2 on the back are a little more difficult, but we're going to follow the same process. So we've got 5x and then x squared plus 9 to the 4th power dx. Okay. So I'm going to begin by thinking of u as whatever's inside of the parentheses. So that will be x squared plus 9. And just like in the previous examples, I am going to take the derivative of u. So it'll be du equals. Now if I take the derivative of x squared, that means I move the 2 to the front, keep the x, but subtract 1 from the exponent. So 2 minus 1 would be just 1. So the derivative of x squared is 2x. And the derivative of 9 is a constant, so that's 0. So it's going to be 2x dx. Now just like the other examples, I want to plug something right back here in for dx. So over here, I'm going to divide both sides by 2x. That way, those will cancel, so I'll have du over 2x equals dx. So now I'm going to take the u's and substitute them back in over here. So I'll still have the integral symbol. Now this 5x will still stay as it is. That's not part of u. The u is what is inside of the parentheses. So u to the fourth. And then instead of dx, I'm going to use du divided by 2x. Okay, so before we do the integral, we can do a little bit of simplifying. For instance, this x right here could cancel with this x right here because they're diagonal from each other. So then I have the constant numbers 5 and 2. So think of that as the fraction 5/2. So like in the previous examples, I could take out or factor out the 5/2 and then use the integral symbol, and then I'll have u to the fourth du. So taking out the 5/2 kind of simplifies it a bit, so you can get your integral faster. Okay, so now we're going to do the integral of u to the fourth. So keep the 5/2 there, and then I'll put parentheses. So this is a polynomial, so think of the 4, add 1 to that, that would be 5. So it would be a fraction, 1/5 u to the fifth, and then plus c. Okay, so next we're going to multiply 5/2 times 1/5. So in this case, the 5s would cancel out and you would have 1/2. So that'd be 1/2 u to the fifth plus c. That would be the simpler form. And then in your answer, you just want to take the u that you found back here, the x squared plus 9, and plug that in. So it would look like this: 1/2 times x squared plus 9 plus c. Final answer for number 4. Okay, so checking that, we can, oh, sorry, I need the 5th power. Yeah, don't forget the 5th power. All right, so by checking that, I will take the derivative of this answer and see if it matches the original problem. Okay, so what you do is you take the exponent 5, multiply that by the number in front. So 5 times 1/2 would be 5/2. I would keep the inside the same, x squared plus 9. The exponent is now subtracted by 1, so that would be 4. And then remember, you also have to multiply by the derivative of the inside. So we talked about this earlier. The derivative of x squared would be 2x, and the derivative of 9 would be 0. Okay, so it's almost to what it should be, but not quite. So now the 2 here and the 2 here will cancel, so that would be gone. And this 5 and that x at the very end, oops, can't really see it, sorry. The 5 and the x can go together, so that would be 5x. And then you still have x squared plus 9 to the 4th power. So notice that this does match the original problem. So that was checking our work by doing the derivative. Okay, so one more and we'll be done for today. Number 5. We have an integral of 2x squared multiplied by 3x cubed minus 1 squared dx. Okay, so this one's a little more complicated, but we can handle it if we follow our steps. So first of all, we're going to say that u equals, and use whatever inside of the parentheses. So in this case, it'll be 3x cubed minus 1. Okay, then we're going to take the derivative, so du will equal. So to take the derivative of 3x cubed, remember you multiply the 3's, so that would be 9, and you subtract 1 from the exponent, so that would be 2. And then negative 1 is a constant, so its derivative is 0. So you're going to have 9x squared dx. So I want to plug in something over here for dx, so I'm going to need to divide both sides by 9x squared. That will cancel those, and I'll have du over 9x squared equals dx. Okay, so go back in and fill in the u's. So the 2x squared at the beginning, just keep that the same. It's here that you replace with u, since u is 3x cubed minus 1, and that is still squared. And in place of dx, you're going to put du divided by 9x squared. Okay, so we can simplify this sum. So for instance, the x squared here can cancel out with the x squared here because they're diagonal from each other. And then you have the constants. You have a 2 on top and a 9 on the bottom. So think of that as the fraction 2/9. So you're going to put 2/9 on the outside of the integral. That will make it easier. And inside, you would still have u squared du. Okay, so now we're going to do the integral. So keep the 2/9 the same. Take the integral of u squared. So remember, add 1 to the 2, so that would be 3. So that would be 1/3 u cubed. Oops. I almost forgot to put plus c. Okay, so now I will multiply the 2/9 and the 1/3. So fractions just go straight across. So 2 times 1 would be 2, 9 times 3 is 27. So it would be 2/27 u cubed plus c. And then in the last step, you would plug in u from what you originally made it, which was 3x cubed minus 1. So your answer would be 2/27 times 3x cubed minus 1 raised to the 3rd power plus c. The final answer for number 5. Okay, checking it means you take the derivative of your answer, and hopefully it'll be what you start with, because that would mean you did it right. Okay, so first of all, you would multiply the 3 exponent by the 2/27. So let's do that up here. 2/27 times 3, think of it as like 3/1. Keep the inside the same, so that's still 3x cubed minus 1. But remember, the exponent is now 1 less, so instead of 3, it's 2. And then you have to multiply by the derivative of the inside. So remember, the derivative of 3x cubed was 9x squared, and the derivative of -1 is 0, so you don't need that. Okay, so how can we simplify this up? Okay, so back over here at the beginning, the 3 can cancel with the 27 because 3 goes into 27 9 times. So that's really 2/9. So we have really 2/9 at the beginning. But then we have the 9x squared on the end. So what you would do is multiply 2/9 times 9x squared. So the 9's will cancel out, because one's on the top, one's on the bottom. And then you can combine 2 with x squared, like multiply them. So that would be 2x squared. And then you would have the parentheses the same. Sorry, I'm reaching way over here. Yeah. So notice that what we ended up with here is the same thing as what we started with up here. Okay, so we got it. All right, I know that was kind of a longer video than usual, but this is a new process, and I wanted to make sure you understood how to follow all those steps. And in our next video, we will continue with more examples that are a little trickier than those. So hope you all are doing well. And Wednesday is interim report day, so please get all your assignments in by Wednesday at noon. Take care, you guys. Miss you. Bye-bye.